All right, everyone. It's time to get started. I appreciate you tuning in on this Wednesday morning. I'm going to answer all your questions at the end, so stay tuned for that. If you want to ask questions, please go to webcast.cloudposse.com for the interactive chat. Again, that's webcast.cloudposse.com, Posse.com. I'll be sharing a link to the final slides at the end, so you can have that for your record, pass that along in your office, or share with friends. All right, everyone. It's time to get started. I appreciate you tuning in on this Wednesday morning. I'm going to answer all your questions at the end, so stay tuned for that. All right. My name is Eric Osterman, and today it's my extreme pleasure to talk to you about Docker. It's something that I'd always dreamed of having, but seemed always far out of reach. My background is in software development. Most recently, I was the director of cloud architecture for CBS Interactive, and prior to that, I advised lots of startups. So what's my objective today? And that is to convince you that Docker is the evolution of cloud. It's not a revolution. It's just the next logical step that you're going to need to take to modernize your infrastructure and reduce risk. So what I'm talking about today is going to be inherently complicated. But don't worry, I've got lots of pretty pictures, and I'm going to try and make this as simple for you as possible. But so we're all on the same page. Let's first talk about what the problem is. So today it's 2015, and companies, specifically software companies, are still struggling at shipping software. Shipping software is a lot of moving pieces. Many pieces are outside of your control. To date, most solutions I've seen are symptomatic. We've been doing the same thing for decades. Basically, it's called configuration management. Configuration management has been confined to the box, both physically and metaphorically. And outside the box, we have real-world problems that we got to deal with and real-world expectations. So there's a lot we could do that we don't, because it's either too risky or it's too tedious. So a couple examples of that are A/B testing and continuous integration. If we could deploy faster, roll back easier, shipping software wouldn't be so bad. Once upon a time, we had a simple blog, and it was called WordPress. Then we tried to scale it. What we ended up with is this, and it's a spider web of loosely coupled services. All of this is done for HA, and even then, it's incomplete. My guess, however, is that you run a lot more than WordPress. You run all this to work together. There are dependencies, there are upgrades you got to deal with, and how do you do that without making you go mad, driving you insane? On top of that, you have more flavors of cloud than ever, and still some die-hard bare metal fans. It shouldn't really matter where you run your stuff, right? All you really care about is having compute capacity, raw compute capacity. So let's focus on delivering that. Because what we have today is this, the matrix from hell. With every new software component that you add, the system's complexity is multiplied by every place you might want to run it. Until recently, there haven't been any novel solutions. In fact, it got so bad, I quit my job. I never wanted to work with cloud again. Living on a beach sounded pretty good to me. So I went traveling around the world for a whole year. I saw 14 countries, 30+ cities. It was freaking awesome. It was because cloud computing started to look a lot like this, a Rube Goldberg machine. Have you heard of them? They're like self-operating napkins, and they're going to be the next fad, especially when it comes to configuration management. There's so many options. You see, at some point, you got to take a step back and reflect. Kind of like what I did. Is this the best way, or is this absurd? Many projects have sprung up that all iterate on the same basic principle: tweaking configuration file snippets, ensuring packages are installed, shipping the kitchen sink, and heck, while they're at it, shipping the entire kitchen along with a chef. It's been done before. They're called configuration management tools, and they manage software the way it's been done forever. Some add orchestration. Some add things called DSL, domain-specific languages, over configuration files, basically making it easier for humans to write. But they all operate inside the box. They don't fix anything because the OS is the problem, the operating system. If we can solve a way to deliver bundled services, things get a lot simpler. We don't have this level of complexity that we got to deal with. So case in point, this is what a typical execution of a configuration management software looks like. This happens to be Puppet, and this is not a criticism of puppets. I love puppets and Muppets equally, but they belong on stage. The point is that something so complex is fragile by nature. We should cut the strings, untether it, and build something that is anti-fragile. So the declarative nature of configuration management is not bulletproof. Moreover, even when it works well, it's painfully slow. Why go to hell and back to ship software? We want to go to heaven. That's immutable infrastructure. You build it once, and that's it. There's no patching. There's no maintenance. It's simple. You have two actions: deploy, destroy. Anytime you want to make a change, you bake a new image and you ship it. Yes, that's slow if you only have one server. But hear me out. If you only have one server, everything I'm going to talk about today is going to be overkill. If you have dozens, shipping a golden image is definitely going to be faster. So what's the difference between imperative versus declarative systems? Well, imperative systems define the process and not the outcome. It's what you see is what you get. It's exactly that. It's not a new concept, but the tools until recently hadn't caught up to make this something easy. The other dilemma is related to virtual machines. The realization that we could emulate servers with a hypervisor was brilliant. They got us to where we are today, kind of like training wheels. But now it's time to get the wrench out and take those training wheels off, because virtual machines aren't the end-all be-all. They aren't the final solutions. They are boxy. Sure, they're not as boxy as bare metal, but they aren't exactly vacuum sealed. Suppose you have 10 virtual machines on a physical server. Then imagine all the redundant processes that are running in each one of those machines. You have SSHD, syslog, crondy. For each virtual machine, you have these processes and dozens more taking up precious resources without contributing much value or solving your problems. We still depend on configuration management today, largely in part because virtual machines aren't exactly penalty-free to instantiate. They take minutes to boot and are billed by the hour. I think seconds would be a much more appropriate unit of measurement if we could. So there's no reason for machines to linger if you don't need them running, such as if you want to fire off a cron job every 20 minutes or every 15 minutes. You don't need a server for that. You just need some compute capacity, right? So if you come to think of it, virtual machines are a lot like trucks. Both have payloads. Compared to trains and cargo ships, trucks are way more expensive to operate. You shouldn't need an engine, chassis, gas, or a driver for every single container. So you shouldn't need a virtual machine for every service you're going to try and deploy. You can fit a lot of containers on a ship, but the 405, my friend, is at capacity. You get it, I think. So that's why the modern day cloud has come to this. It's a bunch of heavy machinery on even heavier machines. All I really care about is the payload. So if this was an MTA bus and we're moving people, you could agree this is all going to look pretty absurd. So can't there be a better way? I mean, there's an opening here for an opportunity to do something better. Well, thank God that somebody was hard at work while I was sipping pina colada on a beach. You see, what if I told you there was a way to magically run any application on any distribution from any vendor using any cloud, and it could just work? You get all of this without sacrificing good architecture and design. In fact, it gets even more badass. You'd probably question my sanity at this point. That's what I was doing for a while, but hear me out. There's a movement happening that might change your opinion of what's possible. So you ready for the big idea? It was inspired by this. It's the shipping container. Back in the 1950s, they created an ISO standard for containers. These are set measurements for how containers are built, everything from how they're open, locked, stacked, and loaded. Today, there are a few different standards, but the principles remain the same. If you need to move something, make it fit inside one of these containers, and you're good to go. Combined with railways, highways, and ships, containers are moved all around the world. Trucks are really just for the last mile of delivery. Unfortunately, some companies haven't figured that out, and that's why we have congestion. They also invented orchestration. Cranes like these load containers onto cargo ships to distribute the load. Massive cargo ships take thousands of containers at a time across open oceans. And then shipping companies lease these containers to you along with space on ship. They work all around the clock and reach every part of the world. It makes it a very efficient process. So you see, it's been solved before in other industries. Let's try to ship software like IKEA ships furniture. We'll call it the IKEA pattern. If it fits, it ships. So what's the secret sauce? Well, I'm about to tell you. It's Linux containers. Linux containers is LXC for short. They're a way to ship pre-bundled Linux operating systems that operate in isolation, just like virtual machines. There's something called the duck test. You might have heard of it. If it looks like a duck, swims like a duck, quacks like a duck, it's probably a duck. Well, containers quack a lot like VMs. They quack all the time. They provide all the essential benefits of virtual machines, but without the overhead. Containers are elastic, or as I like to say, shrink-wrapped. They take only as many resources as the underlying processes, and no pre-allocation of resources is necessary. One size truly fits all. Best of all, you know that cron job I was talking about? Well, containers start up in instances, so you can easily fire up that cron job and be done with it. Virtual machines and containers are similar but different. Don't worry, it's not complicated. Containers are designed to share as much as possible while maintaining isolation, while virtual machines, on the other hand, are designed to share as little as possible, just the bare metal. Because containers share as much as possible, they take fewer resources. It's as simple as that. If you follow the single process per container model, then you'll have a very lean operating machine. So a little known fact is that containers have been around as we know it since 2008. Google built them to power their infrastructure and then gave them to Linus. Thanks, Google. The problem is that LXC by itself is too complicated, and the implementation varies by Linux distributions. That's why it's taken until 2014 for containers to make front page news in operations. The reason is Docker. Docker created the necessary abstractions to bring LXC to the mainstream. Essentially, it combines three things: chroot, cgroups, and namespaces to create app isolation. Inside a container, processes only see other processes in that container. They have only access to their own file system. Processes are jailed, they can't break out. So inside a container, it really begins to feel a lot like a virtual machine. And here's the kicker. Inside a container, there's not even a single process running by default, not the Docker daemon. So this is a single process that runs once per physical machine or virtual machine, not per container. So it's very lean. Docker is a, you could think of it almost like a container hypervisor, but it's not really a hypervisor at all, since the heavy lifting is done by the Linux kernel itself. libcontainer was written by Docker and is responsible for the interaction with LXC. It's kind of like libvirt for cloud if you've done any low-level cloud programming. Docker files are like make files if you've done any C program. They define how the image should be built. The simplest way to think of a Docker file is it's kind of like a domain-specific language that borrows from Bash. They are super simple. You're going to learn how to write one in about 30 seconds if you've previous experience in Bash. And the product of this Docker file is a fully baked image. Baked images are like AMIs if you're using Amazon, or like VMDKs if you're familiar with VMware. They're based on AUFS, which is a layered file system. If you're familiar with journaling, it's a lot like that. Basically, every change you make results in a new layer to the file. When you need to ship this image, you're really just shipping the new layers, the deltas, so it's very efficient. Containers are like running images. Think of them as instances in the traditional sense. You can attach to them much like you can attach to a virtual machine, and inside containers, you're typically not running all the standard processes you're used to seeing. So you're not running syslog, you're not running SSHD, you're not running crondy or a chef agent. All that stuff would be wasteful. Repositories now, these are where you store your images. They're not a new concept, and they work just as you can imagine. So in the Docker ecosystem, you have Docker Hub, and that's like the main repo, and there are other ones popping up. The Docker client uses an API. The API is RESTful, and it can be done over network sockets or Unix sockets. All communication is done over encrypted SSL sockets to control this daemon. The Docker client can be run locally on a laptop just as easily as you can run it on the server. So now a little bit about the Docker Hub. The Docker Hub is kind of like GitHub, but for containers. It's very popular, and it maintains the lineage of all your images, basically the history, so you can go back and forth through versions. And what's cool about it is you can get pre-bundled images straight from the vendors. There are a lot of repositories out there, thousands of them. I think in this, you can see there's 2,100 of them. And most of these are not going to be official. But when you do find an official repository for the software you want to work with, I do suggest you work with it because it's typically higher quality. There are also going to be some security gotchas, so stay tuned. I'm going to get to that at the end. Briefly, here is what the Docker file looks like. The point here is just to show you that they're simple. If you've ever written a bash script, you'll learn how to write this Docker file in about 30 seconds. It's that easy. 1, 2, 3, 4. Well, maybe not even 30 seconds. I think maybe about 5 seconds is appropriate. The Docker command line tool is very intuitive, especially for any Linux admin. There's no crazy arcane syntax you're going to have to worry about. Here we have an example of a new image being generated and pushed to a remote repository. It's kind of like a git commit followed by a git push origin master if you're a developer. The magic with Docker is that you can change this one environment variable, Docker host, and suddenly these commands are going to get executed on a remote server. So that could be a remote server like a virtual machine on your laptop, or it could be a cluster of 1,000 nodes in your data center. So let's entertain a new possibility, given all of these new tools that you've seen. There are runtime environments to run Docker on your laptop. For OS X, you have 2 easy options. One is called boot to Docker, and the other one's called Kitematic. They're trivial to install and take 0 configuration, but that's just a tool, right? Now you have to figure out how you're going to run your applications on your laptop. So to do that, you have a couple options. One is Docker Compose. Docker Compose was formerly called Fig, and it has this simple YAML configuration format that describes how you're going to run your containers and how they're linked to each other. So you can compose them. Or if you prefer, you can still keep using Vagrant. You just need to install the plugin for the Docker provider if that's easier for you. But be warned that the concept of using Docker is a little bit different than the concept of using Vagrant. You're not going to do all this configuration management that you're used to doing. You're going to spin up a pre-built image. The magic is that you can run dozens of these containers on an average laptop, but you could never do that with traditional virtual machines. So this really allows you to run a much more complex architecture locally for development. So here's a quick glimpse of Kitematic. Incidentally, they were just acquired by Docker last month, I think. Personally, I use boot to Docker because I live on the command line. I don't need GUI, but if the command line intimidates you, use something like this. Developers have now the option to compile their code locally, make sure it's all working, build the image, and ship it to QA. QA can now test that image, make sure it's kosher, and then ship it to production. Because containers are so cheap, you might as well take advantage of it. Let a few canaries loose in production and see if they fly as expected. If they don't, just shoot them down. Use the Docker kill command for that. All of this opens up a lot of exciting opportunities for production. So in production, you can have now the peace of mind knowing that you're running exactly the same code as was packaged by the developer and tested and then verified by QA. You're reducing risk because containers are imperative. They are exactly what you defined. To automate rollouts, just define new containers pinned at the right version and leave the old ones laying around just in case something doesn't go as planned. So the way you do a rollback is easy too, kind of like what I alluded to in the last slide. You basically kill the problematic containers and you're back to your stalwarts. The more containers and microservices that you leverage, the more you isolate your failures. So get this, Guild Group, the fashion company, they treat every single page of their website as a standalone application. We're talking login, logout, search, checkout. These are separate applications. Now that's serious isolation, but there's a cool consequence of doing things this way. It means that you can change any part of your application, your website, without a full-blown rollout. Now that's pretty cool. It's taking microservices to the extreme. Use them to their maximum advantage. It's a new way of thinking. It's going to take you a little while to get your head around it, but you can do cool things. Like if you had tried to do this with virtual machines, it would be cost prohibitive. You cannot run that many virtual machines. So continuing on this thread that containers are so cheap, you should be running more A/B tests. And this is how businesses can take advantage of using Docker. In fact, you can run those tests with totally different dependencies than you could before. You could test that certain libraries perform better than others. Because deploying software is easier, it can be done more frequently, and you should deploy more frequently. Anything that's awkward, you need to do more of. And the faster you can determine the results of a deployment, the quicker you can minimize risk. Think of high-frequency trading, like on stock markets. The less market exposure you have, the safer you are. So businesses want to minimize risk, maximize reward. This is how you do it. If a test is performing poorly, nuke it, and you're back to square one. Now, CapEx, capital expenditures. Now, the way to maximize your CapEx investment is to better utilize existing hardware. Basically, your sunk cost. You've already spent money on. Containers are dense by nature, so they're going to be your best bet. Run more software on the same servers. Related to this, now you can reduce your OpEx, your basically operating expenses. Why? Because as a result of the increased density of services, you have fewer servers, which means less power, heat, network ports, etc. So you get the idea. In case you're wondering how to visualize that, it looks something like this, and this is what I dream of. So the question on everybody's mind at this point has got to be, is it production ready? Hell yeah, without a doubt it is. Remember, the underlying technology is mature, even if Docker itself is pretty new. You see, LXC is used by Google in production to power their entire infrastructure. Now, Google does not use Docker, but Docker itself has now been around for at least a year and a half and is used by very large companies. And a lot of major investment and commits coming from organizations outside of Docker. With Docker version 1.5, they've addressed specifically a lot of the features that enterprises needed in order to be able to run this in production. But hey, don't take my word for it. Take theirs. If you Google some of these names along with the keyword Docker, you're going to find great videos at meetups talking about how they cracked the nut. The real question you need to ask yourself is, are you ready? Now, if you don't engineer for the cloud or use patterns like 12-factor apps, Docker isn't going to do any miracles for you. Docker is designed to make cloud architecture easier. It's not Miracle-Gro. Your architecture won't suddenly scale or grow like weeds. By far, the biggest reason you don't see more companies running Docker is a lack of operational proficiency. It's that simple. As with any new technology, you have to hone your skills, new tools are required, and processes put in place. If you don't already practice the advanced art of DevOps Jiu-Jitsu, Docker is going to feel overwhelming when you step outside the sandbox. So remember, Docker is just this. It's just your engine block. You need something that looks more like this, the container ship. Building it requires a strong opinion for how you want to run containers. There's no right or wrong way. That's up to you. It's your choice. Most of what you read online are going to be simple use cases of single server installations. They leave out all the fun parts doing it at scale. And that's the part that I get really excited about, as you can hear by the intensity of my voice. Taking the leap to production is big, but it does not require a leap of faith by any means. It's important to note that these are not new concepts at all for cloud deployment. It's just that Docker itself does not solve these things. Solving it would require Docker to become very opinionated, and that's not a good thing, because we want to be able to do cool things with Docker and not just do things with Docker the way Docker wants us to do it. So Docker is only a tool. It's about at the same level in your stack as configuration management. Using Docker will, however, make things easier for you. And best of all, you can reduce the size of your Goldberg apparatus. So there's a lot of legit software written to scale Docker across hosts. This is some of it. Before you go out writing your own, because that's the first choice any self-respecting developer is going to do, please do yourself a favor and look at what's available out there. Or ask someone for advice. Maybe ask me. I'm happy to answer your questions. But the main ones that stand out here are Apache Mesos and Kubernetes by Google. And these things are what most open source packages are leveraging right now to do Docker at scale. Basically, these things manage your applications and define a higher level layer to orchestrate your application. Make sure your containers are restarted, do auto scaling, things like that. There are also some security concerns that you need to be aware of. And most of these security concerns are no different than using any of the open source software out there that you take off the shelf. Docker Hub is a public community, just like GitHub. So please remember that. Anyone can publish images, including Bitcoin miners and botnet entrepreneurs. There is no oversight beyond public due diligence and community support. Some images will be certified by Docker, like the one I showed you earlier with that little emblem, but most are not, few and far between, in fact. So your safest bet is to roll your own private repository and borrow from Docker files as you need need that you can find in Docker Hub to get that rolled out. All right, so what's the future of this Docker ecosystem? Probably the coolest thing to expect in the near future is Docker Swarm. Docker Swarm adds the ability to stitch all of your daemons together into one huge virtual server. It's what cloud always promised but never delivered. All Docker client tools will work the same way. They won't even know the difference of who they're talking to, if they're talking to a cluster or a swarm or a single Docker daemon. Much like the Docker Swarm, keep your eye out for Triton by Joint. Joint has much more experience than any other company at running containers at scale. They've adapted SmartOS to run Docker. SmartOS is actually Solaris, and they've found a way to emulate Linux on top of that, and making SmartOS even smarter than you could imagine. They are the only cloud provider that implements something that looks like Docker Swarm. And on top of that, they have something called a ZFS, which is the backing store, so you can depend on the data inside your containers not just disappearing. With Triton, I anticipate Joint becoming a major player in the container space if they play their cards right. They've been around a long time, but kind of just been in the background. Did I mention also that SmartOS is open source? You can self-host this if you actually want that, if that's a requirement of your organization. How awesome is that? So the other option is Magnum by OpenStack. So Magnum is something that is sponsored by Rackspace, and it's how they're going about launching containers for their infrastructure. It's pretty similar to Triton, actually. It lets you run containers on OpenStack, and they pull this off using a combination of Kubernetes and Mesos, as I talked about before. You're going to continue to see massive vendor adoption. This technology is definitely here to stay. It's amazing that both Amazon Web Services, Google Compute Engine, Azure, Rackspace, Joint, and dozens more all jumped on board this in less than a year on this technology. What a massive, monumental engineering effort that must have been inside of these organizations. What's even more amazing is that the boat didn't capsize when they all jumped on board. So you can bet that VMware is watching all of this very closely. So there are going to be some big acquisitions this year. You can bet on that. So to summarize, here's what I want you to walk away with today. Docker is the real deal. Docker gives you raw compute power. It's up to you what you do with it. I'll let you do more with less and in less time, and you can move faster with reduced risk. Best of all, you get all of this without any vendor lock-in. So that's all I got for you guys today. I will tune over to the chat here and continue to answer any questions that you have. Unfortunately, there's a slight video delay here, so I won't be able to maybe answer these in a coherent fashion. So I'll do my best and otherwise answer them on the chat itself. All right. Well, looks like we don't have any questions right now, or there's some technical issues. I just want to say that Cloud Posse, who I work with, provides advisory and implementation services for medium to large scale cloud operations. If you have any questions or are interested in how to work with Docker, I encourage you to reach out to me. My email is eric@cloudposse.com. That's Eric with a K at cloudposse.com. All right, we got a one question here from Mada. Can we run daemons inside of Docker, or is it only meant for batch processes? Oh, yes. So here's the thing. Docker containers can run any Linux application. You can run MySQL, you can run Redis, you can run anything you would run inside of a traditional virtual machine will run inside of Docker. The example with a cron tab that I brought up earlier, for example, that was just to demonstrate that you can do very short-lived processes. You can have containers that only run for a matter of seconds. And that would have been pretty much prohibitive in the traditional virtual machine environment. I'd also like to mention that the webcast.cloudposse.com, this is actually running on Docker, on CoreOS, behind vulkan-d. vulkan-d is this mesh router that is aware of all your backends. So since there are no questions right now, I'm just going to continue talking a little bit, and feel free to chime in if you have any questions. I want to talk about some of the technologies that have been built for the Docker ecosystem here. And that is, for example, SkyDNS. So SkyDNS is a dynamic DNS service that's aware of all your other backends in your cluster. And you can do that using another service called Registrator. Registrator will poll the Docker daemon and find all running Docker containers and add a DNS entry for them automatically. This is pretty cool because what you can do is then delegate a zone to your cluster from your domain. For example, cluster1.cloudposse.com. I could delegate that to my cluster and then have DNS entries automatically created. The other challenges with any cloud environment will be service discovery. So how are you going to do that? And in the Docker ecosystem, etcd is clearly the leader in this. etcd is a distributed key value store, and it works a lot like Memcache. But the difference with Memcache and etcd is Memcache data is not replicated between your Memcache nodes. And if you lose one Memcache instance, you're going to lose that data. Well, etcd implements the Raft protocol and will elect a master in your cluster to be the authoritative source. All your keys are replicated to all other etcd nodes, and it's fully fault tolerant and masterless. It's not designed for performance, but for service discovery, performance like etcd is like Memcache-d is not required. I mean, you can still probably do thousands of lookups a second, but it's not like Memcache, which is geared for hundreds of thousands. The other challenge with a Docker-like ecosystem is data logging. How do you find out what's running or going on inside of all of your containers? By default, Docker containers are going to be logging to std out. If you make your applications log to std out, then you can run the docker log command to get that output. All right, we got another question here. Can you describe a little bit more about the methods or services to manage the up status of containers? One example would be if any container fails, the best practices to notice and bring it back up. All right, so this is a very good example and probably one of the most common examples that people are going to learn the hard way if they go to production with Docker and haven't done their tests. So Docker by default will only restart your process a certain number of times, and that's configurable. That's why a lot of people rely on something else, which is typically systemd. Systemd is the init replacement for Linux. Every major Linux distribution is switching to systemd. So most of my experience is with CoreOS. So I'm going to talk to you about how it's done in CoreOS to ensure that your service is always running. So CoreOS uses something called systemd in combination with something called Fleet. Fleet is basically this layer that sits on top of systemd and manages all the systemd processes in your cluster. Systemd is then responsible for managing all of your containers. Systemd will then start your container, and if it fails, it'll restart it. You have the option of having a delay. So restart this container only every 30 seconds or only every 5 minutes. Basically, you don't want to have your container restarting all the time because you might take out or use up a lot of compute resources in doing that. The other issue to think about is what to do when you start a Docker daemon, essentially. How do you start your services? Docker itself will handle that your services will start on boot. But again, if it fails more than n times, it's not going to restart that service. I really suggest using something else to make sure that your containers are always running. This is also where Kubernetes comes in. So Kubernetes defines this concept of a pod, and a pod are all these like services that are running that need to be always available. And you can say how big that pod is. So for example, you might put Apache inside of a pod, and you say you need 5 instances, or basically 5 containers of Apache. Now, Kubernetes is going to make sure that you always have 5 of these containers running. So another thing I'd like to bring up are backups. If you're going to try and run MySQL, for example, on this environment, you really need to have a serious backup strategy. So there are a couple ways you can do this, and I'll talk about the easiest way you can do this at first, and that is basically you, well, okay, going back to immutable infrastructure, remember that you have 3 layers. Basically, you have the volatile layer, you have the static layer, and then you have the identity layer. And the only layer in the MySQL case that you need to really back up is this volatile layer. And that volatile layer can be done in 2 ways. Basically, you can mount a volume on the host's file system. So if that container dies, that volume will always persist. It's just a mounted directory. But then you also have to worry about how to back up the directory if the entire host goes away. So to do that, I recommend you use something called duplicity. And duplicity is a really cool package that will do incremental backups and send them basically to any endpoint that you want. And that endpoint could be Amazon S3, or it could be Cloud Files, or something like that. The other option is, and this is not necessarily recommended, but you create a data volume, and that data volume, you mount that data volume to your MySQL container, and then you can actually run a Docker command to push it back to the repository. Here's the problem with that approach is that you can only have a certain number of layers. So if you're doing a commit every hour of your data volume, you're eventually going to run out of layers. Off the top of my head, I don't remember what that limit is. It is you can redefine it, but you're going to have to recompile AUFS or something like that. One thing I don't think I covered to answer Gilman's question was how to see maybe what's running. So to see what's running, you would run the command docker ps on the command line. The problem with this is that if you are literally running hundreds or thousands of containers on a machine, docker ps is going to be overwhelming. You really need some way to view these things as a composition composed of a higher level service. So this is our web tier, and what are all the components that make up our web tier? To do that, I haven't yet seen any really nice solution. The closest thing you're going to get is Docker Compose. While Docker Compose today is written to mainly satisfy development environments, with the advent of Docker Swarm, it's entirely possible to run Docker Compose against a production environment. And that's the direction they're going. If you want to skip the whole operational burden of running containers, just use Triton by Joint. Yes, it's in a private beta right now, a preview release, but I want to emphasize that Joint has so much experience running containers, I expect it to be very, very stable. So with the Joint supporting basically something that looks like Docker Swarm, you can point Docker Compose directly at Triton by Joint. All right, so going back to logging. Logging is a challenge within a containerized environment. So containers are generating logs inside of them, and basically the data inside of containers you can't easily access. Therefore, you always want to ship your logs outside of containers. And how do you do that? You have a couple options. Basically, you can have your applications ship your logs directly to a service like Log Entries or Papertrail app, or you can have them ship them to another syslog container running on the server and worry about how you ship the logs from syslog somewhere else. Or the third option is basically you mount a volume, you bind mount a volume to the host operating system, and you ship your logs there. In the end, you always want to get the logs off of the host machine, because that host machine could possibly go away. And I recommend using, again, duplicity as a means of doing that. If you actually need the raw logs. Also, I want to point out a few things here. So Datadog and log entries both have containers that you can get from the Docker Hub that make logging very easy in the Docker ecosystem. They will use the privilege. They need to be privileged Docker containers, and then they attach to the Docker daemon and get the std out logs and ship those std out logs straight to their service. And you get a lot of insights by doing that. The other thing I didn't really touch on too much is the containership. So the containership is basically where you're going to run all your containers. While there's nothing preventing you from just apt get install Docker or Docker IO on your production servers, that is not the best way of running Docker. Basically, you want a very lightweight, purpose-built operating system, just like you had purpose-built container ships. So there are like 4 or 5 of these purpose-built operating systems. And the main one right now, the leader, is CoreOS. So CoreOS has a major backing with Google. And in fact, they just launched something called Tectonic. Tectonic by CoreOS combines the best of Kubernetes and Mesos with CoreOS. So it's pre-packaged and bundled. Your other option is Ubuntu Snappy, and Snappy is with, well, and that's obviously by Ubuntu. Hold on, I got another question here. So this is not directly related to Docker, but on logging. Any thoughts on the best ways to handle non-stable internet connections if you're shipping out all of your logs? This is a very fair question, and it's one that I've been disappointed with, frankly. So to describe the problem, in case everyone's not aware, is if your application is trying to ship out its logs in real time to a third-party service, for example, Datadog, and Datadog goes down, you're going to miss that window of logs while Datadog is down. So your best bet is to do something like queuing. How can you queue your logs, especially if you're generating gigs and gigs and gigs of logs? Well, you have a couple options. If logs are this mission critical to your organization, anything that you need done right, you need to do it yourself. So then you're going to want to build a logging infrastructure locally and handle that situation. But shy of doing that, what I recommend is logging. The individual containers should be logging to the host file system using a bind mount, and then you have a separate process that is responsible for shipping these logs to a remote service. That remote service could be Papertrail app, log entries, or Datadog. Now, Logstash is a frequently used tool for doing this. Off the top of my head, I don't believe that Logstash will back off if your remote endpoint has gone away. We had this problem when I was at CBS. My buddy Niraj wrote a specific utility for us to ship our logs with this in mind. So basically, it would back off and wait and queue the logs if the remote endpoint is not online. All right, so I was talking, before that question, I was talking about purpose-built container operating systems. And these type of operating systems are designed very differently from a traditional operating system. So on a traditional operating system, the way it works is you type a command like apt get install package. You're installing just that package, and that package might be curl or something, or wget. The difference with a container-based operating system is container-based operating systems have no package managers. They have no packages. Well, so they do have packages, but packages are containers. So the way you actually install packages on a container-based operating system is you run the Docker command and you run docker pull and the package, and that installs it onto the system. So the operating systems that work that way are Snappy Ubuntu, Project Atomic, which is by Red Hat, CoreOS, and Rancher. Rancher is a new upstart. A buddy of mine, David Getzler, is doing some consulting for them and turned me on to that. Rancher looks like a really cool operating system that borrows a lot from CoreOS. Every single thing is installed via containers, even the kernel and the RAM disk. Now, you can't run the kernel, of course, inside of a container. You can't run the RAM disk inside of a container, but you can use containers as a packaging system to ship software and ship software consistently. So you're not making any exceptions. All right, well, I'll just continue blabbing my mouth here. Cluster HQ. Cluster HQ is a really cool startup. They have both an open source component and a enterprise component that you pay for, basically support. What Cluster HQ is trying to do is solve the problem of what to do with your data volumes on Docker. And this is the big problem if you have anything where persistence is required, your Redis server, your Mongo server, or your MySQL server. So if you're used to using Amazon Web Services, you're going to be familiar with the concept of snapshotting. Snapshotting is a way to efficiently take a backup without taking a complete snapshot. You're only taking the deltas, basically the data that changed. Well, Cluster HQ is trying to solve the volume management component of Docker. Also, there was an interesting thing I read when I was looking at Rancher. Rancher seems to have some concepts of volume management, but I have not looked into it yet. All right, so I'm going to talk about Fleet. And what is Fleet? So Fleet is a distributed system, and it's a way of managing systemd in a cluster. Fleet is just a very, very thin layer. And all Fleet does is store its configurations and commands inside of etcd, and etcd takes care of all consistency and replication and uptime. And Fleet now runs on every one of your host servers, like every one of your CoreOS servers. There's another component called fleetctl. Fleetctl is something you can run on your laptop, or you can run on a Bastion host, or you can run on the server itself. And what Fleet does is it submits systemd configuration files to the Fleet daemon, and then the Fleet daemon submits those to systemd. This makes for a very consistent way of managing your services. So if you want to define a service that's global, you can use this extension called xfleet. Would be the section, and you say global equals true, and then you can create a service, and you'll call it maybe HA proxy, and you'll say that HA proxy is a global service. Now what Fleet will make sure is that this service is running on every single one of your hosts on your cluster. The other concept of Fleet are tags, basically metadata. So you can tag hosts as having certain properties. Maybe certain servers have higher disk I/O, or higher network I/O, or more RAM. Now you can have a section of your unit file that you submit to Fleet that basically says, I have an affinity towards servers that have a lot of RAM, or I have an affinity towards servers that have very fast network throughput. This is how you can now efficiently run service on the servers that make the most sense to run them. All right, I'm going to talk about two other commands that you might want to know about, and those are, well, I will talk about Docker machine. Docker machine is a very simple command, and it's something that you can install locally on your laptop. And what it does is it allows you to very quickly spin up a image that's running Docker on pretty much every major cloud provider out there. You have Amazon Web Services, you have Join. Well, I'm not sure if they have Join support, to be honest. They have Rackspace Cloud and Azure and Linode. The list goes on and on. So if you're just getting started with this and you want to have some place to run your containers in a persistent fashion, this would be one way you can get started. I'm not necessarily recommending you use Docker machine to spin up your production cluster, because you're going to need a lot of custom tooling. But at least to get up and running or get a test environment going, Docker machine is a great way of doing that. The other aspect of this I haven't touched on is as much is orchestration, and the lowest level of orchestration. How do you orchestrate your actual CoreOS servers? And these are, or well, okay, suppose you're using CoreOS, since that's what I'm most familiar with. So somewhere you have to run, somewhere you have to instantiate the actual virtual machines or the bare metal to have that. And to do that, there are still some dependencies on configuration management, and specifically configuration management software that is cloud aware, so it does orchestration. And a great example of that would be Ansible. Aside from Ansible, a lot of people are using SaltStack, and the other option is Terraform. So if you're familiar with Vagrant, Vagrant is kind of like the local development version of Terraform, and it's by the same company called HashiCorp. So HashiCorp created Terraform so you can create a basically DSL that defines your architecture that works in any cloud. If you're familiar with Amazon Web Services and what is it called? CloudFormation. CloudFormation is a opinionated way to launch your infrastructure that runs specifically on Amazon Web Services and only on Amazon Web Services. Well, Terraform is a way of doing something just like CloudFormation, but on any cloud. If you're familiar with Juju by Ubuntu, they were trying to do that as well, but to me it seems like Juju is a dead project. Well, I think that pretty much wraps up this podcast for today. Thank you so much. I will be available for further questions via email if you shoot me something there. Otherwise, give me a call anytime, and hope you guys enjoyed it. Take care.